Look at our planet from space. It's not brown or green. It is a brilliant, shimmering blue. We call it Earth, but a more honest name might be ocean. This vast, global body of water is the defining feature of our world, the cradle of all life, the engine of our climate. We have mapped its surface in incredible detail. But the surface is just a thin, sunlit veneer, a liquid skin. Because beneath that skin lies a world of profound darkness, crushing pressure, and secrets so strange they rival anything we could imagine in outer space. This is the deep ocean, a realm that makes up over 95% of the living space on our planet, yet a place we know less about than the surface of Mars. It is the last true frontier on Earth. And today, we are going on an expedition. We are leaving the light behind and descending into the abyss. We will meet creatures that manufacture their own light, witness volcanoes that erupt mud, and explore landscapes that have never felt the touch of the sun. This isn't just a list of facts. This is a journey to an alien world that happens to be on our own planet. And the things we find there will change how you see the world, forever. So take a deep breath. We're going down. Our journey begins the moment we leave the sunlit zone, or the photic zone, which extends down about 200 meters, or 650 feet. This is as far as sunlight can penetrate the water. Everything below this point is in a state of perpetual twilight, and then absolute, eternal darkness. The moment we cross this boundary, the fundamental rules of life change. Photosynthesis, the process that powers almost all life on land, becomes impossible. So, how does anything survive down here? The answer is one of the most important secrets of the deep. It survives on snow. Not the snow you're thinking of. This is marine snow. It's a constant, gentle rain of organic debris from the world above. Dead plankton, fish scales, fecal pellets, bits of dead animals, all of it slowly drifts down from the sunlit world, providing a meager but steady supply of food for the creatures of the Twilight Zone. It is a world that lives on the ghosts of the world above. And the competition for this falling food is fierce, which has led to some truly bizarre evolutionary adaptations. As we descend into the Twilight Zone, or the mesopelagic, from 200 to 1,000 meters, the pressure is already immense. At 1,000 meters down, the pressure is about 100 times what we experience on the surface. It's the equivalent of having a grand piano balance on your thumbnail. And yet, this zone is teeming with life. In fact, scientists now believe that the fish of the Twilight Zone, creatures like lanternfish and dragonfish, account for up to 95% of all the fish biomass in the entire ocean. There are more fish in this dark, cold, high-pressure zone than in all the rivers, lakes, and sunlit seas combined. Their numbers are estimated not in the millions, but in the quadrillions. So why have most of us never seen one? Because they are masters of stealth. To survive in a world with no place to hide, the creatures here have developed the ultimate camouflage. They have learned to become invisible. Many have transparent, gelatinous bodies that are nearly impossible to see. Others, like the hatchetfish, have silvery, mirror-like sides that reflect what little light there is, making them blend in perfectly. But their most ingenious trick is a phenomenon called counterillumination. Many fish have light-producing organs, called photophores, on their bellies. They can control the brightness of these lights to perfectly match the faint, dim light filtering down from above. So, if a predator is looking up at them from below, their silhouette is completely erased. They are using light to disappear into the darkness. It's like a real-life Klingon cloaking device. But what happens when you go deeper? Past 1,000 meters, or about 3,300 feet, we enter the midnight zone, the bathypelagic. Here, there is no sunlight. None. The darkness is absolute. The pressure is crushing. The water is near freezing. And the food is incredibly scarce. This is where life gets truly weird. This is the realm of monsters. You've probably seen pictures of the anglerfish. It's the stuff of nightmares. A grotesque, globular fish with a mouth full of needle-sharp, transparent teeth. But its most famous feature is the fleshy lure that dangles from its head, which contains a glowing ball of bioluminescent bacteria. In the absolute blackness, it uses this light to attract curious prey. A small fish sees the light, swims in for a closer look, and in an instant, the anglerfish's huge mouth opens and swallows it whole. Talk about a bad date. But here's the unbelievable secret of the anglerfish. The ones we always see, the terrifying ones with the lure, they are all female. The males are tiny, parasitic creatures, sometimes less than 1/100th of the female's size. Their only purpose in life is to find a female. When a male finds one, he bites onto her body and latches on. His body then physically fuses with hers. His eyes, fins, and internal organs wither away until he is nothing more than a permanent, attached pouch of sperm, drawing all of his nutrients from her bloodstream. Some females have been found with over 6 males permanently attached to them. It is one of the most extreme and, frankly, creepiest examples of sexual dimorphism on the entire planet. In this world of darkness, light is the universal language. It is estimated that over 90% of the creatures living in the deep sea can produce their own light, a phenomenon called bioluminescence. But they don't just use it for attracting prey. They use it for everything. The vampire squid, which is neither a vampire nor a squid, can release a cloud of glowing, sticky mucus to blind and confuse predators. Other creatures use flashes of light to attract a mate, or to startle a predator, like a deep-sea burglar alarm. Some even use red light, which most deep-sea creatures can't see, as a kind of secret sniper scope to illuminate their prey without being detected themselves. It is a silent, dazzling conversation of light, a constant fireworks display happening in a world of total blackness. But to see this world, we need to go down. All the way down. Our next destination is the abyssal plain, the Abyssal Zone, which stretches from 4,000 to 6,000 meters down. These are the vast, flat, sediment-covered plains that make up the majority of the ocean floor. For a long time, we thought these plains were barren, lifeless deserts. We were wrong. They are home to a host of strange creatures, perfectly adapted to a life of darkness and scarcity. Here you'll find the tripod fish, which rests on the seafloor on 3 long, stilt-like fins, waiting for tiny crustaceans to drift by. You'll find sea pigs, which are a type of gelatinous sea cucumber that looks like a bloated, multi-legged piglet, hoovering up sediment. And then there's the food. How do large animals survive here? They wait for a miracle. A whale fall. When a great whale dies on the surface, its massive, blubber-rich carcass can sink to the abyssal plain. This single event is a food bonanza that can sustain an entire ecosystem for decades. The first to arrive are the scavengers, like the grotesque, eel-like hagfish, which can tie themselves in knots to create leverage to rip off flesh. After the soft tissue is gone, a new set of creatures moves in, zombie worms, that can dissolve the whale's bones to get at the fatty lipids inside. A whale fall creates an entire, complex, multi-generational community, a temporary island of life in the vast abyssal desert, all centered around a single death. But the ocean floor is not all flat plains. It is a world of immense, dramatic geology. The longest mountain range on Earth is not the Andes or the Himalayas. It is the mid-ocean ridge, a 65,000-kilometer long mountain chain that wraps around the entire globe like the seam on a baseball. This is where new oceanic crust is born, where tectonic plates are pulling apart and magma is constantly welling up from the mantle. And scattered along these ridges, we find one of the most incredible discoveries in the history of science. In 1977, scientists in the submersible Alvin were exploring the Galapagos Rift. They were expecting to find a cold, barren volcanic landscape. Instead, they found something impossible: towering, chimney-like structures, some several stories high, spewing superheated, black, mineral-rich water into the freezing ocean. These were hydrothermal vents, or black smokers. The water jetting out of them was over 400 degrees Celsius, hot enough to melt lead, but the immense pressure of the deep sea kept it from boiling. But that wasn't the impossible part. The impossible part was that these vents were teeming with life. They were covered in giant, blood-red tube worms, some over 2 meters long, with no mouth, no gut, and no anus. There were ghostly white crabs, strange fish, and beds of giant clams. How was this possible? This was an entire ecosystem thriving in total darkness, at crushing pressure, surrounded by toxic, superheated chemicals. The discovery of hydrothermal vents completely rewrote the rules of biology. The secret to this life is a process called chemosynthesis. The water from the vents is rich in hydrogen sulfide, a chemical that is highly toxic to most life on Earth. But specialized bacteria have evolved to use the energy from this chemical to create food, in the same way plants use the energy from sunlight for photosynthesis. These bacteria form the absolute base of the food chain. The giant tube worms have these bacteria living inside their bodies in a symbiotic relationship. The crabs and clams feed on the bacteria, an entire world, completely independent of the sun. This discovery opened up the tantalizing possibility that life could exist on other worlds, like Jupiter's moon Europa, which we believe has a deep, dark ocean with hydrothermal vents on its seafloor. The search for alien life on Earth redefined the search for alien life in the cosmos, and the vents aren't the only strange oases. Scientists have discovered cold seeps, where methane and hydrogen sulfide leak out of the seafloor, supporting similar chemosynthetic communities. They've even found asphalt volcanoes in the Gulf of Mexico, where thick, tar-like asphalt erupts from the seabed, creating bizarre, solid structures that are home to a host of unique creatures. And then there are brine pools. These are underwater lakes of super salty, dense water that doesn't mix with the surrounding ocean. You can literally see the shoreline and the surface of the lake. But this brine is incredibly toxic and contains no oxygen. Any fish or crab that accidentally swims into one is instantly pickled and dies. They are underwater lakes of death. So naturally, we had to send a submersible to go for a swim, right? But we can go deeper. Beyond the abyss lies the Hadal Zone, named after Hades, the underworld. This is the realm of the deep sea trenches. These are the deepest parts of our planet, plunging from 6,000 meters down to the very bottom. The most famous of these is the Mariana Trench, and its deepest point, the Challenger Deep, is nearly 11,000 meters, or almost 7 miles, straight down. If you were to place Mount Everest in the Mariana Trench, its peak would still be more than a mile underwater. The pressure here is over 1,000 times that of the surface. It is the equivalent of having 50 jumbo jets piled on top of you. It is a pressure so extreme it warps the laws of chemistry and physics. And yet, there is life here. Delicate, shrimp-like amphipods swarm the bottom. And a strange, tadpole-like creature, the Mariana snailfish, is the undisputed king of the Hadal Zone, the deepest living fish ever discovered. It has a gelatinous, uncrushable body with no scales, and its bones are not fully ossified, allowing it to survive in a place that would instantly turn us into dust. We've descended from the Twilight Zone to the deepest trenches on Earth. We've met monsters, seen living light, and discovered ecosystems that thrive on toxic chemicals. You'd think we'd have a pretty good handle on this place by now. But here is the most unbelievable fact of all. We have only explored in detail less than 5% of our own ocean. And as for the ocean floor, we have better, higher resolution maps of the entire surface of Mars and our own moon than we do of the bottom of our sea. Over 80% of our ocean remains unmapped, unobserved, and unexplored. What else is down there? We are constantly discovering new things that defy our expectations. We have discovered a shark cafe in the middle of the Pacific, where great white sharks travel thousands of miles to congregate for reasons we still don't understand. We have discovered a single living organism, a network of Poseidonia seagrass in the Mediterranean that is estimated to be over 100,000 years old, making it one of the oldest living things on Earth. We have discovered colossal squid with eyes the size of dinner plates, the largest eyes of any animal on the planet, which battle sperm whales in the deep. And we have discovered that some deep-sea sharks, like the Greenland shark, can live for over 500 years, making them the longest living vertebrates on Earth. There are sharks swimming in the ocean today that were born before the United States was a country. And with every new dive, with every new remotely operated vehicle we send down, we find new species. Scientists estimate that there may be over 1 million species in the deep sea that we have yet to discover. The potential for new medicines, new biological processes, and a new understanding of life itself is immense. The deep ocean is the largest museum on the planet, but we've barely stepped through the front door. But our impact is getting there before we are. We have found plastic bags in the Mariana Trench. We have found traces of man-made chemicals in the bodies of the creatures that live there. The noise from our shipping and seismic surveys is disrupting the communication of whales and dolphins. And as our climate changes, the ocean is absorbing over 90% of the excess heat and 1/3 of the carbon dioxide, leading to warming, acidification, and deoxygenation, all of which threaten these fragile, ancient ecosystems, most of which we haven't even met yet. The final and most urgent secret of the deep is that this unknown world is in danger. And the clock is ticking. We began our journey by leaving the sunlit world behind, descending into a realm of darkness and pressure. We found a world that lives on snow and communicates with light. We found oases of life that thrive on poison, and creatures that survive in the most extreme environments on our planet. But the greatest discovery of all is the realization of how much is still left to be discovered. The deep ocean is a library of 1 billion untold stories, a testament to the tenacity and the sheer, weird inventiveness of life. It is a reminder that the greatest adventures and the most profound mysteries are not always light years away in space, but right here, under the blue surface of our own world, waiting for us to just keep looking. And if you believe that exploration and discovery are some of the most important things we can do, if you were captivated by this journey to the last frontier on Earth, then join our expedition team. Hit that subscribe button and turn on notifications so you don't miss our next journey. And if you know someone who needs to see the unbelievable alien world that shares our planet, share this video with them. Every single share helps us grow and continue our mission of exploration. Thank you for diving deep with us today. The mystery is out there,